list. So something like this, it has duplicates, so we just need to remove all the duplicates. So after removing the duplicates, so this is the output we are expecting. So 1, 2 and 3. So can you tell me how can you solve it? Can you tell me how can you solve it?
Yeah, it's a sorted list only, right? We can compare current with the next.
How long you will compare?
This is the
Can you talk about brute force? So yeah, will you? Yeah, so let's discuss about brute force approach. Then we will move on to optimistic solution.
it's not good books.
No, no, yours is optimal, but I'm just. Can you tell me what is brute force approach?
I thought that was a brute force.
Sorry,
I thought that was a brute force only, which I told you.
I can't hear you. Can you speak little louder?
I thought whatever I told was brute force.
Oh,
Approach.
that's not brute force. Ajay,
Compare the
Maitri.
current node with the next one. If it is same, then skip that node and connect it with the next node.
Yeah, that is optimal. That is what Akash told. Okay. So if you don't know, if you don't get a thought, how do you do it? Generally, you might have used a set.
Two
Then you
loops.
will load all the elements into the set. So there is a set of integers. So you will load all the elements. So that set will have 1, 2, 3. Then you will take these values and return it, right? What is the problem if you use set? Will it work?
Yes, it will work. We will have just new
But set doesn't maintain the order
space.
of elements, right? We need to
But this
return the same
given
list,
list
right?
is already sorted, right?
Yeah, list is already sorted, but if you there are assume that there are 10 power 5 elements, and assume all the elements are unique, and you loaded all the 10 power 5 elements into the set. Now when you take the values from the set, right, does it guarantees insertion order? So have you tried
If
any
the
time?
input is
So assume you have
the
used
input is
as
sorted,
set.
then I think the order will maintain, right?
Generally, if you go with has set, right, it will not maintain the order. So we should go with linked has set. Okay, so if you go with linked has set, it will maintain the order, so that the elements will be presented in the linked has set. Again, you can reconstruct the list and return it. Clear, right? So what is the time complexity here? What is the time complexity here?
Order of n.
Order of n, right? So we just traverse the complete list, and we copy all the elements into the linked has set, and so that is taking linear time. Plus, then again you take the values from the linked has set and reconstruct the sorted list, so which is also taking linear time, but obviously which is going to be 2n. And what is the space complexity here?
Order of n. We are using actual.
So because we are using has set, so which is going to take order of n, right? Now, yes,
And
Maitri.
for newly created a linked list, even that.
Yeah, so that is also taking order of n, correct. So this is for set and this is for linked list, right? So this is the brute force way, and now let's try to optimize it. So how do you optimize it? Okay, so let me keep this. So if you want to optimize it, how do you optimize it? So this is your list. So this is your list. Let's say I have one again here. So 1, 1, 1, 2, 3, 3. So how do you come up with it? So how many pointers you need, tell me? How many pointers you need, tell me?
For the brute force or
No, forget about it. Tell me whatever thought you have, we will talk about it. Any idea how many pointers you need? I need to compare two elements, right? For sure. Yes or no?
Previous and next.
Right? So I need to compare two elements so that I have one pointer here and one pointer here. Right?
yeah.
Why like current dot next also will get right?
But how long you will compare it? Okay, so you will, then how do you get the actual list, right? So you need a list 1, 2, 3, right? How do you get this list?
Yeah,
We can
we can compare current at next with current at next.
Okay. Okay, so what you are trying to say, I compare current dot next with current dot next. Okay. So this is valid and this is also same. So that what you do, you are trying to replace this with current dot next. You are replacing with 2, right?
Current at next. We will replace with current at next.
Then
So
how do you
suppose-
compare the next elements?
We are iterating through loop only, right? That's why loop.
So what you are trying to say is,
So first, now the current equal to current at next. We will compare. So that was if condition.
mm,
So inside, we'll update the current at next with the current at next.
okay. So this will go. Okay.
Yeah. So now these two will be there.
Mm.
So if the next, so it will, in the next iteration, it will come here,
Okay,
right?
so it will go.
It will, yeah, like that.
Then what you do? Now, so now you are here and this is current and this is current dot next, right?
Yeah.
Mm. I got your idea. Try to implement by yourself. Yeah, so definitely if you go with that idea, so when you come here, you can do that, but your code is not going to be cleaner and yeah, so you need to just give a try. So whatever thought you given, so which is correct. But if you closely see, based on your identification, so this one and this one will go away. So here is the current and here is the next value. Both are not equal. Then you come here, then you compare this. So both are not equal. So you come here, then you compare here. So these two are equal. So you will just compare with the, you will just append the next. So which is null. Then which one you will return now? You need to return 1,
We
2,
will have
3,
a
right?
dummy.
So which one you will return now?
We will return first current.
Yeah. So what is that current?
Dummy head dot next.
Yeah. So whatever it is, either it is head or dummy head dot next. So it's a good idea. We can implement that. So let me apply the same concept here, but I will try to make it as a little cleaner code. So what I will do, I will keep a, so whenever you are working with linked list problems, right, always work with dummy nodes. So it will be very much helpful. So first I will create a dummy node. So this is my dummy node and this is my current. Okay. And I take one more variable. So next. Okay. This is my current and this is my next. Okay. So now if you see here, so if you see here, yeah, so if you see here, so my current value and next value both are same. So what I will do, I will move next to the next pointer. Again my current value and next value both are same, so that I will move next to the next pointer. Okay, so next to the next pointer. Closely understand. So initially, okay, so initially this is my current. Let me make it more clear. What is the input you have? So the input will have negative 100 to plus positive 100s. Okay, so let's say you have current and you have next pointer here, and this is my dummy node. So initially I'll make dummy dot next as current, so which is obviously 1, I'll make dummy dot next as current, so which is 1. Okay, so now current and next both are same. Current value and next value both are same. It's time to move further because I need unique values, right? So I'll move next pointer furthermore. So next is here. Again current and next are same, so that I will move next pointer furthermore. Okay, now if you closely see, my current and next both are different, so that I will add current dot next equal to whatever next pointer you have, that's it, 2. Okay, so initially my current is here. Okay, so for clarity's sake, initially my current is here, so same current. Now if you closely see, I compared the next pointer with the current. So whenever I feel like my next pointer is not equal to current, and I'll make sure that my current dot next equal to next. Okay, so whatever next pointer you keep, I just made it, and I just increment the current furthermore. Now current is here. So current is here. So again, obviously you will increment the next. Now if you closely see, this is my current is 2 and next is 3. So current and next both are not equal, so that I will make current dot next equal to whatever next pointer you have, which is 3. Now whenever I add a current value to the current, so I will increment the current. Now I'll just increment the next also. Next is normally increased. Now if you closely see, this is my current and this is my next. So current value and next value both are same, so that I'll just move next further, so that whenever next is equal to null, so you will just return. So if you closely see, this is my dummy head. To the dummy head, I just initially I added current and I just keep on updating it, so that at last I can just return dummy dot next, which is going to be 1, 2 and 3. Do you understand what I am trying to say?
Yes.
So what is the time complexity here?
It is linear.
So it is linear, right? So what is the space complexity?
We are not considering dummy, right? So constant.
We are considering dummy, but dummy doesn't have additional space, right? It will reuse the same nodes, so that space complexity is constant. Okay. So let me go little quick. So if you didn't get idea earlier, so you can get now.
So for initially for dummy node, we'll set 2 head, right?
So this is my dummy head. Okay, so this is my dummy head. So this is my next pointer. Okay, so I'll make dummy head next is going to be whatever head which is given, so which is 1. So this is my current pointer. So now I'll compare current value is equal to next value, so that I'll move next, and current value is equal to next value, so that I'll move the pointer, and current value is equal to next value, so which is 1 equal to 1, so again I'll move further. Now current value is 1 and the next pointer value is 2, so which is different, so that current dot next equal to this next, and I'll increment the current and I'll also increment the next. Now current is 2 and next is 3, so which are different, so that I'll increment current dot next equal to next, so which is 3, and I'll increment the current and I'll also increment the next. Now if you closely see, my current value is 3, next value also 3, so that I don't add this next here, then I'll just move further. Now when you increment next is reaching null, so that you can just return dummy head dot next. That's it. So it will just return the actual input, required output. Clear, right? So the code is very simple. So what I'm saying, let's go with dummy. So we will just take list node of so list node, so which is dummy. So I'll just make dummy dot next, which is equal to head, and I'll also make current equal dummy dot next. Then I'll also take one more pointer, list node next pointer, whatever it is, so which is going to be head. So I will just write a logic Just a second. So while your next pointer is not equal to null,
Right?
sorry,
Current should be head, right? Line number 15.
can you closely? That is also fine. You can make current head or dummy dot next, whatever it is. Both are
No,
same, right?
next pointer should be head dot next. No, that's why. Or are we
That's
pointing
okay.
to
That's
same
okay.
node?
That's okay, na. So anyhow, we will handle here, right? If current
Machine line
dot
number
value
16,
not equal
next
to,
pointer should be head dot next.
that's
right?
okay. I understand your point. You can do this, right? So you can handle here, right?
Yeah, anyways, with the while condition, it will be handled.
No, but for the first iteration, we'll be comparing the same nodes, right?
That's why we don't add it, right? So it's fine. Even this is also doesn't, even none of the things, both will work, na.
Okay.
Because here we had a if condition. It's okay. Anything will work. So whenever the current value and next pointer value not equal, then we will update current next equal next pointer, and we will move the current pointer, and next pointer as usually keep on moving till the end of the list. So at last we can just return dummy dot next. Correct? Correct, na? Yeah, so what is the mistake here? Tell me. So this is very critical point. If you closely see, we got 1, 2, 3, 3, 3, right? So what is the mistake we got here? Can you tell me what is the issue we had at code? And this is a test case. So generally what is happening here, if you closely see, this 3, right? This 3, this is the 3 we are adding, right? Correct? Correct, na? Yes or no?
Yeah.
So this is the 3 we are adding, and we are not adding this 3, but still we are getting the additional 3. Why?
We didn't make current that next should be made null in this.
Yes,
once.
obviously. Why? Because we are adding this 3, right? This node, right? This node next is 3, right? This node next is 3. So we added this node, and this node is having next pointer which is 3. Even though we didn't add it, so when they iterate, obviously this is holding next node which is 3. So that what you should do, you should make the last node next as null. So that when you make last current next as null, it will work. Understood?
Okay.
Understood. So if I add one more 3 here, so if I add one more 3 here, so what will happen? It will come, all the 3s will come, right? Because so you see, so we added one more 3. So we added first next, but the first next will have the reference to next 3, and that will have reference to the next 3, that will have reference to the next 3. So that what you should do is, once you get this current is pointing to the last node, right? Make sure that current dot next, which is going to be null, so that things will be smoother. Hope you understood it. Okay, so what is the mistake here? Tell me. What is the mistake here? So he has given head as null. If head equal to null, you can simply return head. that's it. So no questions, right? So there is no concept here, it's simple plain logic. Okay, so let's move on. Yeah, so we need to find out whether the linked list is having cycle or not. So how do you know that? For example, this is your linked list. So you have one, two, three, four, five, and yeah. So this is the linked list. Is it having cycle? It is having cycle, right? So once you reach node 3, so you keep on repeating on the same loop, right? So once you reach node 3 and there is a cycle, so you will again keep on repeating on the same loop. So this is cycle. So for example, if it is something like this, if it is something like this, then there is no cycle. So we need to return. So in this case, cycle is present, so that we should return true. Here we should return false. So how do you solve it? How do you solve it? Can you tell me what could be the brute force solution?
I mean, we traverse to the end of the list. If the end of the last node doesn't have null, then it has a cycle.
How do you know there is a last node?
I mean, the length. First we traverse to the length, and then
How do
we
you know?
find
It will end up into loop, right? You cannot find
Yeah.
a length, na?
It's like before.
So once you come here, you get number 3, then 4, 5. Again you will come here 6, 7, 8, 9, 10, 11. So you will end up in loop, right?
Same like before, we can take the set, we can iterate to it.
So one easiest solution is set, right? So set of nodes you can take, set of nodes, and you keep on adding to the set. So initially you added 1, so 1 is not present. Then you added 2 because 2 is not present. Then you added node 3 because 3 is not present. Then you added node 4, 4 is not present, and you added node 5. So once you added node 5, so node 5 dot next is node 3, right? So again you try to add, you check that node 3 is already present. So you check that node 3 is already present. So as it is present, so you can simply return true, otherwise you can return false. Correct? So if it is in this case, right, if you see 1, 2, 3, so you add 1, 2, 3, then you will reach to the end of the linked list, so that it doesn't have cycle, so that you can return false. But in this case you can return true, right? Is this algorithm clear?
Yeah.
Ajay, Maithili, Kalyan.
Yes.
Right. This is, what is the time complexity here?
Okay.
What is the time complexity?
Order of n.
Yeah, so order of n. And what is the space complexity?
Same order of n.
Because we
Order
are
of n.
using set, right? So that is order of n. Now let's look at the concept here. For example, you have a cycle, right? So you have 1, 2, 3, 4, 5, and here you have a cycle, right? So this is your linked list. So let's say you have 2 pointers. Let's say you have 2 pointers. One is slow, another one is fast. So slow will take 1 step at a time, fast will take 2 steps at a time. So in that case, so initially what will happen? So this is your loop, right? So this is your loop. So slow will take 1 step at a time, fast will take 2 steps at a time. So as it is 1 step, so slow will be here. So fast will take 2 steps, so fast will be here. Now again, Again in the next iteration what will happen? In the next iteration again same thing. So slow is here, so that it is taking one step, so the slow can come here to the next pointer, and fast is here, so it takes two steps, so that 1 2, so fast is here. Now when they are in loop, right, so now if you closely see, slow and fast pointers both are in loop, right? At some point in time they definitely meet. So now again if I do further more,
Yeah, in the next iteration it will.
so if you closely see, slow is taking one step, so slow is taking one step, so the slow will come here. Fast will take two steps, so 1 and 2, so fast will be here. Now slow and fast both are pointing to the same node, then it has a cycle, so that you can return true. Clear? So if it is a simple loop, right, slow is here, fast is here, slow take one step, so slow will be here, fast will be here. Then by then fast is moving out of the loop side, so that you can return false here. So when there is a loop, right, when there is a loop and slow and fast is entering into the loop, at some point in time they will definitely meet, right? So they will definitely meet. So what is the proof? For example, you have a loop here, so you have a loop here, this is your loop, so this is the loop. So slow is taking one step at a time, fast is taking two steps at a time. So it means so by the time when slow is taking two rounds, by then fast will complete that round in hope you understand, this is a simple math, right? Let's say this is your cycle, so that fast is going two jumps at a time, slow is taking one jump at a time to make a circle, right? So by the time fast is taking off iterations, it will reach complete iteration of a slow, right? Because hope you get it, right? I may not explain clearly, but you understood it, right? So that's a concept of cycle. So when there is a cycle, definitely they will definitely meet. What is the time complexity here?
CN.
So linear. So what is the space complexity?
1 order of 1.
1. That's right. We are just using 2 pointers, slow and fast. So that's it. So let me code. So you have you can try for that hash set. I'll just write the optimistic solution. Slow is head, list node, fast is also head. So I will just say as long as fast not equal to null, and fast dot next not equal to null. Just a second. There is no charging. Yeah. So you can say slow equaled slow dot next, then fast equaled fast next. It will take two jumps and this will take one jump. So if you see that slow and fast both are equal, then you can return true. That's it. So otherwise you can return false. So that's it. So yeah, so let's move on. Okay, so remove linked list elements. Yeah. Now, yeah, can you tell me algorithm for it? So simple. So you will be given a linked list. So you will be given a linked list, and you will also be given a value. So we need to remove those values from the linked list. So how do you do that? Let's say this is the input you have. So you have input as 1, 2, 3, 4, 3, 2. So this is a linked list, and you will be given a value as 3. So we need to remove value 3 from the from the given list and return the list in the same order. So once you remove value 3, so we have value 3 as this one, right? So this one and this one. So once you remove it, so this is how it looks like. So 1, 2, 4 and 2. So how do you do that? Can you tell me how do you do that?
We need to remove the complete node.
Yeah, that node to be removed. So whichever node is having this value, those nodes to be removed, and it
Okay,
has to
node dot
maintain the
value.
same order.
The node is equal to value, we can remove it.
Yeah, that node dot value is equal to given value, so we need to ignore that node.
So what we do is we make the previous node next equals to value dot next, value node dot next, so that will be removed while traversing. If you
What
find
if
that
it is
value.
having 3 here?
Oh,
So that is still fine. If there is a 3, we will not. So basically, we'll move the current. Only if the current value and the next value is different, we will not move current if both are same.
I understand your idea, but why are you going so complicated way? Can you come up with kind of dummy concept?
No,
I
dummy concept
understand.
will definitely take it, which will be at the beginning.
Mm.
That is there. What idea is that we will go with current dot next value. If it is equal to the given value,
Yeah,
then current next is equal to current dot next.
that's it. Yeah.
Otherwise, we will move the current node.
Yeah, correct. So this is my dummy node. So first, this is my current, and current dot value not equal to the value, so that I will add the current. Then I will move current. Okay. So you understood, right? So then I will move current. So this is my dummy current. So you will have two variables. So this is my current, and this is my let's say you have a pointer here. Let's say I have a pointer P here, and let's say this pointer is called P1 and this is P2. So initially the P1 pointer value is not, P1 is pointing to the actual node, which is not equal to value, so that I will add the P1, so which is P2 dot next equal P1, so that I will move P2 further because I need to add further nodes. So as usually P1 comes here. Now current P1 value is 2, which is not equal to value, so that you can add P1 again here, so which is going to be 2. So again you will increment the P2, then you usually increment the P1. Now if you closely see, the P1 pointer value is equal to value, so that you don't need to add here, so that simply you will increment the P1. Now again the P1 pointer value is 4, which is not equal to 3, so that you can add P1 here, so that 4 will be added. Whenever you add an element, increment this pointer. As usually you can increment the P1. Now P1 value is equal to P1 value is equal to given value, so that you don't add this P1 here, so that you can increment the P1. Now P1 value is not equal to value, so that you can add P1 here, so which is 2, then you can increment the P2 and you can also increment the P1. So now P1 is pointing to null, so that you can simply return dummy dot next. So this will have actual result. Clear? Ajay, Maithili, Kalyan, Akash. So what is the time complexity here? What is the time complexity here?
Order of n.
So order of n. So what is the space complexity?
Constant.
Constant, right? So this is the importance of dummy node. Okay, so whenever you can solve this problem without using dummy node also, but it is very tough to maintain the references. So whenever you write a code, you will get to know that. Simply what I'm saying, so you will take a dummy node, new list node. Okay, so nice. So what I'm saying, you will have list node. I can make it as dummy current, so which is dummy, and you will also have list node current, which is going to be head. So you will just move on, current not equal to null. So whenever you feel current dot value is not equal to value, then you will add the current to the dummy current. So dummy current dot next is equal to current, and move the dummy current to the next pointer, so that you can add next element. Otherwise you can simply increment the current equal to current dot next. So finally your dummy dot next will hold the complete valid list. So that's it. Tell me what is the mistake we have here. Tell me what is the mistake we had here. No idea. We are getting extra 6, right? So what is the mistake we had?
Same problem that we had.
Same problem, right? So we added 5,
Current dot
but yeah, so 5 is fine, but 5 dot next is 6, right? 6 we didn't add, but through 5 we got the 6. So that whenever you get the last value, right? So last dummy current, right? So dummy current is holding the last value, so make sure that the dummy current dot next is belongs to null, so that you will have valid result. So that's it. Yeah, this is interesting problem. Let's solve this, then you can try other problem. So we need to check whether linked list is palindrome or not. How do you check it? Whether the linked list is palindrome or not, how do you check it? So let me.
let's take 2 pointers, one from starting, one from ending, and then check the values.
How? It's a single direction, right? It's a single linked list, na?
Oh. Oh. Yeah.
So what's happening? So we have 1, 2, 3, 2, 1. Is it palindrome? Is it palindrome or it's palindrome?
Yes.
Right? So we should return true.
Yes, it's correct.
Yeah, how do you do that? How do you do that? Can you tell me brute force? Then we can think about optimistic solutions.
Take link hashtag and maybe insert everything.
Sorry, Michael, can you be little louder?
Take a link hashtag and insert everything, and then maybe we can.
Okay, so if you take linked hash set, it maintains the same order, right?
Yeah.
But you need to compare first value with the last value, no? Value is same and this is middle, so you can ignore it. So that's why it is palindrome, right? But if you go with linked hash set, so what will happen? You will again have 1, 2, 3, 2, 1, right? So if I give 1 here, then your linked hash set also will have same thing, 1, 2, 3, 1, 1. So again it will compare. Actually this is not palindrome, but that will return as palindrome. So you need to compare first value with the last value. How do you do that?
We can do that with simple array also, right?
Yeah.
Take
so
an array, insert everything, then compare zeros with last element.
That's it. So that's the brute
First
force
increment.
solution, right? So you can take an array
Yeah.
list. You can take an array list. So all the values will be inserted into an array list, and you will compare first value, last value, first value, last value, then done. So you are done with this is true, this will return true. So this is a concept of array list. So what is other solution you could think of? So you need to take 2 pointers here, right? But can you think of other solution? Can you think of what is the time complexity here? So first we copy all the elements into array list, right? So obviously which is linear, and then again you compare, you traverse the array list to check whether it is palindrome or not. So again which is going to be linear, and the space complexity is linear, right? Because we are taking array list, right? So what could be other brute force solution? Okay, I don't know array list. Then you want to find out whether it is palindrome or not. So what could be the other solution?
Instead of array list, we could take simple number and also do it.
That's okay. Again, it is array list only. So one more solution could be stack, right? One more solution should be stack. So in the stack, what will happen? So it is like 1, 2, 3, 2, 1, right? So this is how the data will be loaded. But what you should do, so you pop one from the stack and compare with the first node. Okay, this is valid. Then once you pop second value, compare with the second node. This is valid. Third value, compare with the third node. So this is also valid. Fourth value, compare with the fourth node. So this is also valid. Fifth value, and compare with the fifth node. So this is also valid. So this is also same concept, but instead of copying into array list, you can use stack. Okay. Now
you can use the string builder also, right?
Whatever you want. Concept remains same, right? So anything is fine. Okay.
So can we do like this? Can we reverse the list and compare with the list that we have initially, and we can have 2 dummies, and then can we check like that?
Okay, if you reverse the list, actual list will change, right?
That's what I'm saying. As we have dummy, right? Can we maintain a dummy and then we first add the first value to one dummy?
When you are reversing a list, I understand your point. When you are reversing a list, what are you doing? For the current node, whatever value you are having, that is reversing, right? To reverse of 1, right? So
yes,
this will affect the current result also, right? It's like you need to deep
we
copy
have to maintain
this.
A new link.
Yeah, so we need to deep copy this.
One more.
Yeah, we need to deep copy this list, then reverse this list and compare. That will also leads to linear space, right? It is like previous solution only, because you need to deep copy the given list.
Current list, correct.
Right. So now we can solve this in constant space. Let's see how can we do that. So 1, 2, 3, and 2, and 1. So can you tell me where should I separate this? Where should I separate this?
At 3.
At 3.
At 3 or at 2? I mean, you mean we need to break here or here? Where do we need to break? Where do we need a break? Here or here? Let me take one more input. So 1, 2, 3, 3, 2, 1. So where is the break required? Can you tell me where is the break needed?
Between 3, 3.
So I need to break here, right? So in this case I need to break here. Let's come here. So for sure I need to compare second list with the first list. I need to compare second list with the first list. If you closely see, if somehow if I am able to make a break here, so my list is going to be something like this, right? So the first list will have 1, 2, 3. Second list will have 2 and 1. Correct? Till now it's clear, right? Till now it's clear, right? Right. Now if you
Yes.
closely see, this is my first list and this is my second list, right? How do you know that these two lists? So it means this first list, when it is an actual palindrome, the second list is a reverse of the first list, right? Correct? Yes or nobody?
Correct.
When it is actual palindrome, for example, forget about odd number. So as it is odd, so that you can ignore this. So if you see, first list is 1 2, second list is what? 2 1. So the second list is reverse of the first list. So what I do, I will reverse the second list. So once I reverse the second list, and this is becoming 1 and 2. So once I reverse the second list, and this is my first list and this is my second list, I will just compare both of them. 1 and 1 equal, 2 and 2 equal. Then when I go further, so that second is out of the loop, out of the list, so that I can return true. Is this clear? The concept is clear. Now when it comes here, obviously I need to break here, so that once I break here, it is 1 2 3, and this one is going to be 3 2 1, right? So that if you closely see, second list is the reverse of the first list, so that I will reverse the second list, so that once I reverse the second list, this is how it becomes. So 1 2 and 3, then I'll compare both, so both are equal, so that I can return true. Whenever there is a non-equal, then I can return false. Clear, buddy? Clear? Okay, so what is the time complexity here? What is the time complexity here?
It's the order of n only.
Order of n only, right? So what is the space complexity?
Order of 1.
Order of 1, correct? So
No
we
additional
don't
space.
use any additional space. Now let's come into the breaking point. How do you do the break, right? So 1 2 3 and 4, sorry, this is 2 and this is 1, right? So I need to do the break. So how do you do the break, right? So simple, right? So by the time, so same concept, slow and fast. To work with even and odd numbers, better make sure that fast is pointing to the next pointer, slow is pointing to the first pointer. Okay, so slow will take 1 step, fast will take 2 steps. Okay, so let's do that. Okay, so when slow is here, fast will take 2 steps, so that fast will be here. So from here 2 steps, so fast will be here. So and again fast can take 2 steps, so that let's move on. Let's again, if you take one more jump, so that slow will be here, and fast is reaching reaching the null value, so you can break here. Now if you closely see, slow is pointing to the end of the first list, so that slow dot next is going to be the second list. So what you can do, the second head, right? Second head is going to be the slow dot next. Okay, so you copy the second head. Then what you should do, make sure that slow dot next is going to be null. Otherwise, you will, if you reference to the same pointer, right, then it is gone. So make sure that once you take the copy of the slow dot next, which is second head, and slow dot next, you make it null, so that this is pointing to null, so that this link will break. Again you can reverse this and start from head and compare both the heads. So both are equal, return true, otherwise return false. Okay, so clear? Algorithm is clear, Maithili, Ajay, Kalyan, Akash. So let me
Here
do
slow
the,
and fast start at different positions.
yeah, why we are starting at different positions, right? Because if you start from same position, na, for odd numbers it won't work. Odd
Okay.
numbers it won't work. So it's a this you will learn through practice only. So you
Sure.
try starting from fast, then for odd numbers it won't work. So slow will come here, so that definitely it will not work. So slow will be here, fast will be out of the loop. then this is going to be the second half. When you reverse it, I think it should.
In that case also, it should be.
No, no. If
I mean,
for even numbers, let's see. For I think it should work. Yeah, yeah. Even if you start from same position, it will work. That's not a problem.
fine.
Okay, so yeah, let's move on. We'll take list node. Okay, so what is our job now? So we'll have list node slope, which is head, and list node fast, which is also pointing to head. Okay, so it's up to you whether you want to go with head or head dot next. It's up to you. We can try both the cases. It's not a problem. Okay, so let's say as per algorithm we discussed, let's move on this way. What I will do, I will just make sure that fast not equal to null, and fast dot next not equal to null. I will just move further. So slow equal slow dot next, fast equal fast dot next. So it's up to you. Even if you go with single same head also, it will point to the right position. So it's fine. Okay, nice. So once you get it, so you know that second half, list node second half, which is pointed by slow dot next. So what you do, first you make slow dot next equal to null, then reverse the second half. So list node of reverse second head, which is going to be, we will write a reverse function for the second half. Okay, so once we reverse it, so you will get a reverse head, and you will also have a first head. So this is head, this is first head, and this is reverse head. So you can write a logic where head not equal to null, and reverse second head not equal to null. So you just move on. If head dot value not equal to reverse head dot value, so you can simply return false. Otherwise, you can make head equal head dot next, reverse second head is equal to reverse second head dot next. That's it. So if everything is fine, then you can simply return true. Okay, so if you want to, so you see here we break the list, right? If you want to reset it, you can add one more logic here, but you can try this way. Okay, so let me write a reverse method, list node of head. So we know this, right? So you will have previous, which is null, current, which is head. You know this logic now. Yesterday we discussed. So first we copy the temp next. So we can make. Hope you are able to follow this. We discussed this yesterday. That's it. So let me run this. Yeah. Let's look at this. So what is the mistake we had? 1121. So what is the mistake we had? Tell me, bro. So it is failed. Can you guess the issue? Where is the issue?
Fast pointer, we are moving only one step.
Yeah. So fast should take 2 steps at a time, right?
Yeah.
Then it works. Again, wrong answer. It worked. Okay, so it doesn't matter whether you can start from same pointer, still it will work. It's not working. Oh. Yeah, it is failed because of 2 pointers. Yeah, so in this case it will fail, right? So if it is can you guess that why it failed? We should start from next pointer. You can think about it, because what is happening here, if you start from same pointer, slow will be here, fast will be here, slow, fast, next fast will move here, slow will be here, and once you reverse it, it will become 2 1. So once you reverse it, what is happening? Yeah, so slow dot next will become null, then it won't work. So this logic will never be compared, so that we blindly return true. You can just have a look at it, so you will get to know that. So both should be on next pointer. Clear, buddy? Clear, Ajay, Maithili, Kalyan, Akash.
Half clear, Shinu. I think this part we need to practice a little bit.
Oh,
to be
this problem,
100%
this
complete.
this solution was not clear.
No, solution, like overall concept is clear.
Hmm.
Like what exactly are doing, that is clear. But when it comes to code, I think we need to do it by ourselves once to be 100% confident.
So actually, what we are trying to do, we are trying to make sure that we are breaking at the right point, second half. Then we will just reverse the second half, and first half is starting from head, right? So head not equal to null, second half head not equal to null. We'll just compare it. When they are coming out of the loop, we'll just return true. Or do you want me to explain the algorithm, or is it clear?
Its algorithm is clear, there is no doubt with the algorithm. The overall concept is clear. It is the code part, I think.
Yeah.
Once we start
Don't look at
practicing
this
it paper,
code.
then
Yeah, don't look at this code. Try to implement by your own.
Yeah.
Then you will get, things will be handy. Okay. I think for today it's fine. So can you try this problem? Can you try this problem? Add two numbers. So simple. So he wanted to add simple addition. So here 2 plus 5 7. Then 4 plus 6 is 10. So 0 will be here. 1 will be carry forwarded. So as 1 is carry forwarded, 1 plus 3 plus 4 equal to 8. So we just need to return 708. So it's a simple math.
with
But generally
can be
math
done.
we do from reverse order, right? But this is in forward direction. So try to give a thought to it. So this is different test case. So you can give a try. It's like making use of dummy node and just doing the addition of two values, and resulted value you can add into the new node and add to the dummy and move the dummy, move the first list 1 and list 2. That's how it works. So try to give a thought. I think you can able to solve it. If you are unable to do it, we can discuss tomorrow.
Sure.
Maithili, Kalyan, Akash, are you clear?
Yeah. Yeah, we need to clear.
Yeah, Maithili, are you speaking?
Yeah, I need to practice the last one.
Yeah. Practice this one. I think I went little quick, but you should able to catch it because it's simply the same algorithm, right? Practice it so that you will get the
Sure.
confidence.
Yeah.